Good afternoon, dear students. Is my voice audible? Somebody please respond. Is my voice audible? Yeah, thank you. So kindly type in your USN in the chat box for the attendance sake. Okay, let me share the screen. Is my screen visible now? Please respond, somebody. Is the screen visible now? Is my screen visible? Yeah, thank you. 1 second. Yeah. Right. Okay. So welcome back to our class on data structure and algorithm. Today, we will discuss about pointers. Last class also we discussed. Normally, whenever you think of a variable will have three components: value, its name, and its address. This address can be stored on a special device, a special variable. We call it as pointers. And of course, if you want to know your address, you can directly type in address of I and value, just I. And as I told, we can make use of an indirection operator. There is an operator called indirection operator. Using this operator, we can certainly print the address value like a pointer. So this indirection operator, that is star, you call it as pointer operator. So normally we can treat this address with a star mark, indirection operator, and we can fetch the value. So this is possible. And that means in this example, it is very clear that whenever we are having a normal variable, and this normal variable can be implicitly, by default, it is also having a pointer. So that is the case. Now, further, how to create a pointer? We have seen this. We can create a pointer by specifying the data type. So the data type is star p, integer pointer or double pointer, and float pointer or character pointer. You have to just specify the data type, and you should use indirection operator in front of the variable name. That's it. So you can create those. And remember one thing, whenever you create a pointer, pointer will not get memory allocation. So it is always dependent on other variables memory. So pointer cannot get its memory. It cannot get memory. So it is always depending on the other variables memory, other variables memory. So in this example, what is that we are doing? We are having a variable x, a variable var that is 20, and this is getting memory address and it is storing the variable. So value, that is variable var. Now pointer p star p is a pointer which is not getting memory allocation. So what you do in this statement, what you are trying to do is you are assigning the value, that is address of pointer p is nothing but address of variable var. So that means this pointer, you are pointing to this particular variable. So what happens whenever you print the variable value? So the value of pointer. So if you want to print the value of a pointer, include a star in front of the pointer variable. So it will print the value. Without star, if you just write, that indicates it is the address. So remember one thing, without star, if you write a pointer variable, it is representing the address. And with the star, if you write, so that represents the value of that particular variable. So pointer variable. Remember in this example, you are printing the address, you are printing the value of a pointer, and you are assigning pointer to address of another variable. So that is one thing that you should understand. Pointers also can be null pointer. Null pointer means pointer do not have any pointing to anything. So you call it as null pointer. You can check whether pointer is null or not. So in this example, if a statement, if you just observe, so if pointer is assigned some value, it is if pointer. If it is assigned some value, that is if it is not null, then this will return true. This will return true. So it will return true. If it is not assigned any value, so that is not pointer. So this will be true only if it is pointer is null. So like this concept, we can certainly use it. This concept, we can certainly use it in various concepts, like pointers can be used with arithmetic, pointers can be used with arrays, pointers can be used with functions, pointers can be used with structures, etc., etc. So they can be used at multiple places. So here is one example, which in turn I have explained earlier also, that demonstrate pointer arithmetic. So you can use pointers for doing arithmetic operations. So look at this particular example. Look at this particular example. So in this example, what we are trying to do is we are creating three normal variables, A, B, C, and three pointer variables, P, Q, R, pointer variables. Look at that. A, B, C gets memory allocation, pointer P, Q, R do not have any memory allocation. Next, what you are doing? A, you are giving value 2, and B, you are giving value 2, and A for 6. Now, P is equal to address of B. P is equal to address of B. That means pointer P is pointing to B. And in the next slide, what you are doing? Q is equal to P. That means Q address is nothing but P address. So where P is pointing, same place Q also will point. So you observe the same thing here. Where P is pointing, same place Q also. And R is going to point to C. R is going to point to C. So this is the meaning of these two. Now, pointer, I told very clearly, pointer can change its address time to time. Whenever it demands, it requires, so it can change from one place to another place, one pointer to another pointer. So what is that pointer is doing? Now, P is equal to address of A. Pointer earlier, it was pointing to B. Now it is pointing to A. It is pointing to A. So now Q is equal to 8. So as soon as you change the value of Q, automatically where Q is pointing, it is pointing to B. What happens? The B value changes to 8. Now, R is equal to P. So R is equal, star R is equal to star P. So that means star P value. Star means pointer value. Value of a pointer, that is 6, is stored in R. Is stored in R. And now R is equal to A. A value is a 6. B star P, that is star Q. Q is 8. And Q is 8. And of course, C is what you are doing. You can see C is earlier value of C is 6. Address of C, it is 6. So the total value 6 plus 8 plus 6 is 20. 20 is storing in R. So that is R is pointing to C. So that is changed. Same way you are printing ABC. So you are printing ABC value. You are trying to print ABC value. So that is ABC means 6, 8, and 20. Same values, star P, star Q, star R. Same way, star P means 6, star Q means 8, star R means 20. So same, these two values gets printed based on this. So this is possible. Now, pointer arithmetic, after you do increment operator for a pointer. As soon as you increment, what happens? Pointer increment. Here, PTR is a pointer without star. So what happens if a pointer is pointing to one cell? Suppose a pointer is pointing, PTR is pointing to one cell. As soon as you encounter PTR plus plus, what happens? Pointer moves to the next cell. It is automatically moves to the next cell. So PTR plus plus means your pointer will move to the next cell. It is going to move to the next cell. It is PTR plus plus. It is going to the next cell. So it is moved to the next cell. So here is one example. I've already shown this example in the last class. Again, I'm repeating. So you have 3 value array. So you have an array. So look at array 10, array 100, and array 200. So you have 3 elements array, and this array is supported by a pointer. PTR you are creating, I you are creating, and PTR is equal to var. I told just name of the array itself, it acting like an address of the array. Or else you can certainly write, either you can write like this, PTR is equal to var, or you can certainly write PTR is equal to address of var of 0. You can certainly write like this, var of 0. You can certainly write var of 0 like this. Now, when you write like this, what happens? Pointer, this PTR is going to point to this particular first cell. Is going to. Now, you are putting a for loop for 3 times. Look at here, I starts from 0. I goes up to max. Max means 3 times. So every time I plus plus. First, you are printing I value, that is 0, and PTR. So PTR value, so that is address. Star PTR means value. PTR means address. It is just printing the address. Now, next, I and star PTR. So the value of the first variable is 10. So it is going to print 10. Next, I plus plus, before that PTR plus plus. PTR plus plus, what happens earlier? PTR was pointing to first cell. Now pointer is going to point to the next cell. It is going to move to the next cell because of this statement. Because of this statement. PTR plus plus, it moves to the next cell. It goes to the next cell. And next loop, it is going to print 100. It is going to print 100. Next again, PTR plus plus, it moves to the next cell. And as soon as you print, so you get 200. So 100, 200, 100, 10, 100, 200 are printed. Once the loop is done, so it is going to be printed. So executed, and it is comes out. Next, pointers you can also use for comparison. So when you compare with the star, the values are compared. When you compare without star, the addresses are compared. So you can see in this example, same, you have 3 cells of a variable that is array, 10, 100, and 200. So what you are trying to do, you are assigning PTR is equal to var. That means pointer is present at this position. It is present at 0 position. Var means just name of the array. Name of the array is nothing but address of the first cell. Address of the first cell. And this address, you are checking whether the address of the first cell is less than address of the last cell, max minus 1. That is this cell. Yes, if it is less than or equal to, then you try to print the value. So it is going to print 10. Now, PTR plus plus, PTR will increment, and I also increment. I also increment because I is being used here. Now, you are checking whether the pointer address is less than the last element address. Yes, it is going to print. It's going to print. There is 100 is going to print. Next, PTR plus plus, it moves. So in this case, is PTR less than or equal to the address of the last element? Yes, it is equal. So since it is equal, it will print 200. Yes, it is going to print. Now PTR plus plus, PTR moves to the next cell. So now the address of the last cell is not equal to or not less than the last element. So automatically the loop stops, and it will come out of the statement and come out of the while loop, and it prints only these 3 values: 100, 10, 100, and 200 are printed. Now, the same way, you can create an array of pointers. So you have array, variable array, you have a normal array with values. So that is 10, 100, and you have 200, 3 values you have. And you are creating an array of pointers. So this is 3 pointers. These 3 are pointers. Pointers now. Now, what you're trying to do in this for loop is you're assigning the first element of the array pointer, that is first cell. It has to be assigned to first cell of the variable. Yes, it is variable array, var array. Next, I plus plus. Pointer of 1 is pointer of 1 is assigned to variable of 1, address of variable. Pointer of 2 is assigned to variable array address of 2. So like this it is arranged. Now, in this loop, after arranging the assigning the addresses of integers to the pointers, in the next loop, what it is trying to do in this loop, what it is trying to do is just trying to print the value of star PTR. Again, I value starts from 0. Star PTR of 0. PTR of 0, that is this cell. This cell is pointing to the var of 0, that is 10 is printed. 10 is printed. Of course, it's not 16, it is 10. Okay, 10 is printed. Now, next, I++. I++ means I becomes 1. So pointer of 1. Pointer of 1 is this one. Pointer of 1 is assigned to variable array of 1. So it is 100. So 100 is displayed. Same way, I++, pointer array of 2. So pointer array of 2 is this one. So pointer of array of 2 is assigned to variable array of 2. So it is going to print 200. Yes, the value. So like this, you can create an array of pointers like this. You can assign like this, and you can print like this. So this is possible with the array of pointers. Next, pointers to pointer. From here onwards, actually, I have not handled. So it was not there yesterday also due to network issue. I missed it. So now you can see pointer to pointer. Normally, you have a variable, and this variable's value is assigned to one pointer. And this pointer is again, it has been pointed to another pointer. Another pointer is pointing to one pointer, and one pointer is pointing to another pointer. So since this pointer is assigned to another pointer is, so this concept you call it as pointer to pointer. So pointer to a pointer is a form of multiple indirection. So it creates a chain of pointers. It creates a chain of pointers. So that is what you should understand. And to take an example, look at here. I have a variable with 300. So I have a 3000. I have a variable 3000, and I have a pointer PTR created. I have a pointer, another PTR is created. This is PTR, that is PTR, and this is double star indicates it is a pointer to pointer, and it is PPTR. So it is PPTR. Now observe here, PTR is equal to address of var. So that means this PTR you are assigning to the address of variable. This is a variable. So the address of PTR is nothing but address of the variable, one and the same. Now, in the next line, PPTR is equal to address of PTR. So this is assigned to address of PTR. Now we are trying to print the variable value. As variable value, it will print a 3000 as it is. Second, star PTR, since star PTR, this star PTR is pointing to 3000. So what happens? It is also printing 3000, the variable. Same way, star double star PPTR, pointer to pointer, which is pointing to PTR, and PTR in turn, it is pointing to variable. This also prints 3000. So this is how the entire pointer to pointer program works. Next, pointer to a function, very, very important. Pointer to a function. So what is that you're trying to do? What is that you're trying to do? You have declared a function here. You can see you have declared a function. So this is get seconds. This will going to give you some seconds, and it will take a pointer value. It will take a pointer value. You just here what you are doing. You are just not declaring. You are declaring. You are not defining the function. You are just declaring the function. Now you are creating a normal variable called a long variable, long integer second. Whenever you want to pass, you have to call a function get seconds. You have to pass some value. So since you are having pointer cannot hold anything other than addresses, that you know very well. So you are passing the address of seconds. So that means So the address of seconds goes to par, and whatever the changes that you make to par, it is affected directly to seconds. And after that, what you are doing, you are printing the seconds. You're trying to print the seconds. And observe this, this function, it is get seconds function. What you are doing, time is the function, time with null. So what this will give you the number of seconds from January 1st. So how many number of seconds that has elapsed from January 1st? So all those number of seconds value, this time function will go into store in star PAR. So, and as you store star PAR is using address of SEC. And what is this going to do? This SEC, when you are printing here, so whatever the value that you have assigned to par in the function call, that value is going to be printed. So the value of the seconds value will be printed. So the same program we can certainly see. It. So I have that program. Let us look into that program. Visualize. Let us visualize that particular program. So I think, yeah, this is the program. Yeah, this is a program we will see. So I think just go to the, okay. This is a pointer-to-pointer program. So where 3000 was pointing and pointer-to-pointer is also pointing, and it is trying to display. So that is a program. Now, okay, so you can see this program. I'll just give, I just paste this program. As soon as I paste it here, so it is not coming. Okay, address of seconds, it is coming only a part of the program is getting. So what I'll do, I'll just take the entire program. Yeah, this entire program, I'll just take it. So just take the entire program and I put it in this visualization tool, and the function also just put it. Function also I just put it. Now this is a complete program. And now I try to visualize this program. And you can also certainly, I'll share the link. You can also, so generate permanent link. I just copy it and I put it in your chat box. You can also certainly work along with me. So you can also certainly click, copy and paste. It will work. Okay. So seconds, and as you change the values to seconds, so you are looking, look at here, as you pass the function, automatically what happens, this second value is being addressed by this pointer PAR. And of course, if I change the value to PAR, it is nothing but I'm changing the value to seconds. And this is 16, 20, 45, 7, 271. This is the number of seconds that is elapsed so far. And of course, it returns. And as soon as I print it, this is a value that is just going to print. So this particular function, directly or indirectly, it is returning some value, okay, based on this pointer assignment. This is called call by reference. Reference here, it is nothing but you are passing the address of a normal variable. That is, you can look at here, the normal variable ampersand second, that is reference, you are passing to the pointer variable. This is call by reference. You are calling by reference. So this program, you can certainly is an example for call by reference also. So that is a program that we can see. Now, similarly, you can pass an array also. Look at here, double, average, get average. So this is a function declaration. So get average is the name of the function that will return a double value. It will take the pointer, it will take the address, some address, and it will take the size, two variable. So what you are doing, you are creating a balance array, which is having 5 elements, 1, 2, 3, 4, 5 elements. And you're calling the function get average. And observe here, just balance you are giving. Just name of the function itself acts like the address of the first element. Address of the first element. So array is pointed to first element, that is balance of 0, and your 5 is sent to size. Now, what happens after it executes in the function? It returns the average value. That average value will be stored in the AVG, and that AVG we are printing. So what is happening in the get average function? So you have an array. You have an array of 5 elements, 1, 2, 3, 4, 5. So first element happens to be 1000, 2, 3. So this is having 1000. This is 2, this is 3, and 17 and 50. So 17 and 50 it is. So now array, it is pointing to first element. And first what you are doing, you are creating the sum. Sum is a local variable and automatic variable. You are finding the sum, array of 0, ARR of 0, that is the first element, ARR of 1, the second element, ARR of 1 is second element, ARR of 2, third element, ARR of 3, fourth element, ARR of 4, fifth element. All the elements sum you are storing here. And finally, you are converting that sum into double and dividing by the size. Size is nothing but total number of elements. Total number of elements is 5. So it is, you are getting it. And it is calculating the average and returning the average. Whatever the average that you return from this function, so that is coming and storing in this average. The same average is printed here. You can see it's printed here. It is printed here. So this is passing an array into a function using pointers. That is the concept. That is the demonstration. Next, you have dynamic memory allocation. So far I was telling very clearly, whenever you create an pointer will not get memory allocation. Now, I want memory allocation for pointer. So what do? You make use of either malloc or calloc. By using these two functions, what you can do, you can allocate memory to a pointer. You can allocate memory to a pointer. Just like in the previous examples, you're allocating memory to normal variable, and from that normal variable's memory, you are assigning the pointer. But here, pointer itself will get the memory allocation based on malloc and calloc. So that is the concept that you should understand here. And in order to do that, you should do malloc is the how much size. So if it is an integer pointer, you have to tell what type of pointer it is. So if it is a PTR is an integer pointer, you just say integer star. malloc is the name of the allocation function and how many bytes. So I am allocating size of integer for 100 such integers. So it will take, so if it is a 32-bit system, integer takes 2 bytes. So 2 into 100, that is 200 memory space is allocated. If it is if it is 64-bit operating system and a 64-bit C compiler, it takes 4 bytes. So 4 into integer of size. So number of size of integer is 4. 4 into 100 is 400. So that's why we write size of integer. Instead of writing the actual size, we write size of integer. Based on the operating system and compiler type, it will allocate the memory. It will find the size of the integer and later it will calculate. So that is the thing. So now look at here. You're dynamically allocating memory for 5 integers. Why 5? N is equal to 5 and size of integer. Each size of an integer may be 2 or 4. It depends upon the compiler type. So based on that, so it will allocate the memory. And look at there, if the memory allocation is successful, then it will get some address. If is not successful, the pointer seems to be null. And if the pointer seems to be null, you can certainly understood, okay, there is some problem with this memory allocation. So what it will do, memory is not allocated. That message it can display. It can display that message. Memory is not allocated. So like this, it can do it. And if it is memory is successfully allocated, so what happens? 5 elements. So what happens if it is a PTR? Name of the pointer is PTR, and you can use like a normal array, and PTR of 0 is nothing but +1. So 5 elements are allocated to a pointer, and 1, 2, 3, 4, 5. So 1 is stored in the first cell, 2 is stored in the second cell, 3 is stored in the third cell, 4th in the 4th cell, 5th in the 5th cell. So it is assigned. So you're trying to put PTR of I is nothing but star PTR. You can now, while printing also, you can certainly print PTR of I. So it works like a normal array. When you do like this memory allocation, it becomes, you can run like a normal array. This is dynamic memory allocation. Dynamically, you can allocate the memory using malloc. Same way, calloc also. Calloc, you have to, instead of specifying the size, you can specify n separately. N is number of elements and size of each element. You can specify. There, what you are doing, n into, you can certainly doing size of integer. You're doing like this, size of integer. That means you are multiplying. So here in calloc, it will automatically multiplies. If you specify n, that's sufficient. So it will multiply automatically. And here 25 elements are created. Each one is of float type. I don't know how much size each float will take. So 25 float numbers, how much it will take, so much memory is allocated to this PTR. This is the meaning of this particular example. After its usage, if you want to remove that variable from the memory, yes, you can certainly use free PTR. If you just do it, what happens? You can remove the pointer. So we have seen pointer to arithmetic operations we have seen, pointers to arrays we have seen, and pointers to normal variables we have seen, pointers to pointers we have seen, pointers to functions we have seen functions, dynamic memory allocation we have seen, dynamic memory allocation, dynamic memory allocation we have seen. Last concept is pointers to structure variables. Very, very important. You create a structure person. We have already created the same type in the previous example. So it is having two members, age and weight. It is having two members, age and weight. Now you are creating a pointer variable, person pointer, and normal variable. Person 1, person 1 is normal variable. For this variable, memory is allocated. So memory is allocated, integer age. This is age, memory is allocated, and memory of weight, that is float that is weight. So weight memory is allocated. Now this is, we call it as person 1. Is called person 1. For this person 1, you get memory. Whereas for pointer person PTR, I just call it PP, person pointer is not getting memory allocated. In the next line, what you are doing, address of person pointer is nothing but address of person 1. That means it is pointing to the first element, that is age. And whenever you store, whenever you want to access them, it is the arrow operator. So using pointer variable, if you want to access the members of the structure, very, very important, you have to make use of this arrow operator. This is called very, very important. Arrow operator. Arrow operator is used to access the members of the structure using pointer variable. So pointer variable is person PTR, arrow person PTR, arrow age. So that is 35 you are assigning, and 65.8 you are assigning. Same thing, I am using it for display. Same, you can do it. The same thing. So it's given in the example also. You can certainly see there is an example. Yes, the same example. Look at here. So here you have the person, and here in the main, as soon as you execute this statement, what happens? Structure person, 2 pointer variables are created. Pointer, see, this pointer gets created. Pointer gets created. Pointer is not having any memory. Observe here, there is no memory for this pointer. And person 1 is having age and weight. And of course, as soon as you execute this line numbers 11, what happens? Memory is being assigned. So pointer person memory is assigned to, pointer is pointed to person 1. That means it is assigned to age. So, and now age, you are using this arrow operator and pointer, you are storing 35. Yes, the same 35 is stored here. Same way, person weight is also, you are storing it, it is stored. Next, you are trying to display age is equal to person PTR arrow operator age. So 35 is fetched. So this weight is also printed. You can see. So this is how pointer can work with the normal variable, structure variable, normal structure variable, how it is. And you can use with the help of arrow operator. So arrow operator is very, very important. And this particular concept which I'm talking right now is very, very important, And of course, this program link also, I just copy it and paste it in your chat box. You can use it. You can certainly use it. This is a program which talks about this particular program. So there is pointers to structure, and that's about this module 1. So before I conclude module 1, I would like to give some assignments. These assignments I'll be posting in the class Google Classroom. Due date is Monday before 5 p.m. You have to write the answers in a piece of paper or book, scan it, and you have to send it to me in the Google Classroom. I'll just post these questions and I'll create assignment 2, the second assignment. And for those who have successfully written first assignment, I have already given grading marks. For second assignment, also the holds good for the same. So it is for second assignment. These are the 5 questions you need to answer and give the solutions and upload in the Google Classroom. Those who have not yet joined Google Classroom, still there is a time you can join, and totally I'll be giving for each module, I'll be giving 3 assignments. Altogether, it will be 15 assignments you'll be writing for the entire course. So out of, yeah.
Can you share the notes personally?
It is already ready. Probably in 1 or 2 days, I'll be sharing in the group. Okay, you can certainly use it.
Okay.
Meanwhile, why I am giving before notes this assignment? Because you will be copying from the notes. So after this assignment, I'll be sending the notes. Okay, definitely I'll give the notes. I'll definitely.
I don't have a.
Yeah, I'll give the notes. I'll give the notes.
Yeah, okay.
Meanwhile, these are all the questions where you have to you have learned from these classes, and also you have textbook. You have to buy the textbook, and the first class itself I told before lockdown, before starting of my class. So somehow you should have the textbook. From the textbook, you can easily. I have got these questions from the review questions that are given in the textbook. So that's the thing. And for these programs, what you have to do, you have to execute the program and give the program as well as output. So you have to take it and you have to submit this in the Google Classroom itself. So that's all for today. In the next class, that is on Monday, we'll start with module 2. That is on algorithms, asymptotic notations, data structure, types of data structures, arrays, etc. We'll discuss. It comprises of chapter 3 and 4 of your textbook. So that's all. Thank you. All of you, please type in your USN in the chat box for the attendance sake if you have not typed. So all the class recordings are available in this particular website. So you can certainly use it. Thank you. Have a wonderful day. Yeah, tell me.